Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. I have this LCD TV power supply board. It is AY250P-4HF01. This power supply is not working. It have no power output at standby. When it don't have standby voltage, at that time it will not provide the secondary voltage. Let's start how we can troubleshoot it. For that purpose, I will connect this board to series lamp. If you don't have a good practical experience in power electronics, never try to repair. I am using a 100 watt. It is 60 watt. I will use 100 watt lamp because it is a PFC power supply. It has PFC circuit, so I will use 100 watt tungsten lamp, simple lamp. If you are repairing a simple power supply without PFC, at that time 60 watt is good, but for these power supplies we need 100 watt. I powered on. I applied power. When the power is applied, don't touch any component in this live side. AC voltage, check voltage at AC input terminal, that is 233 volts. Now we will check DC voltage at this DC capacitor. It don't have any voltage. When it don't have any voltage at capacitor, then there is no concept that there will be some voltage at standby pin. Here is pin marking 1, 2, 3, 4, 5, 6. Locate the marking number 6, that is 5 volt SB. Check on the pin 1, 2, 3, 4, 5, 6. It don't have any voltage. Let's see what is the problem. In the first step, we will remove these back cover locks. One lock is here and the second lock is here on this side. Just only press it and open it. We can see there is no burning sign here. Sometimes we can locate if there is any burning sign or like that, but here is no burning sign. Some pins of the components are touching to the board while removing, otherwise it is looking clean. Now we will start. Now I will apply power and we will check AC voltage. Set multimeter to AC voltage. Check voltage at input terminal. We have 233 volts. Here is fuse, and after fuse the voltage must here. There are no voltage. Check voltage across the fuse. We can see the full supply is dropped across the fuse, so that means this fuse is open circuit. When there is open circuit in electronics, in electrical circuit, no power supply will pass. Let's check continuity. Yes, the fuse is open. Now I will remove the fuse. Fuse is here. It is 6.3 ampere 250 volt AC. 6.3 ampere fuse. Continuity. Yes, it is open circuit. Now I will use 1 ampere bus fuse wire, and I will use 3 wires, so it will become 3 ampere. And after testing, we will install the original fuse. I am installing this fuse just for troubleshooting. When we will confident that the fault is removed, at that time we will install the actual value fuse, and we will place in this way. Now I will apply power. We can see the lamp is fully on. That means there is something short circuit. Now to start troubleshooting, the first step, we need to verify the PFC section. We need to test this boost converter. There are MOSFETs and the rectifiers. We need to check it, and then we will continue. Now I will remove this heatsink panel. Because it is too difficult to remove the screws for the MOSFETs, so it is better to remove the heatsink panel. Now I remove the heatsink panel. Now we will check these MOSFETs and rectifier and bridge rectifier. Set multimeter to diode mode. Black lead at the positive terminal of the bridge rectifier. Put at AC input terminal, center pin, 1 diode, it is good. Now move black lead to this side. Check with the inner terminals, it is open. It must be open, that's good. Swap the leads. Red lead to the right pin, that is negative pin. Check with AC terminal, it is good. Now move black lead to this cut side, positive terminal. It is open, the bridge rectifier is good. Side terminals, black lead at this terminal and red lead at this terminal. We will find 1.02, 2 diodes drop voltage. In the input terminals, it's good. Check this rectifier, it's good. Check this MOSFET. .517, touch to the gate, it's okay. Now move to place red lead to the center pin and touch to black lead to the left pin. Now it must be open, it's good. And reversing the leads, 1 diode drop voltage, that is good. Check this one, it is short circuit. Now place red lead in the center terminal and touch here, 1.91 volt. It must be insulated, so it is short circuit, and it is giving continuity here. That means this rectifier, this MOSFET is short circuit. 13 and 50, MDF 13 and 50. Now I will replace this MOSFET. Now I installed this MOSFET and we can check now. This one is good. Black lead to center pin, this to right pin. Now it is 1 diode resistance. Reverse the leads, it is open. Black lead to center pin, drain pin, touch red lead to the gate to charge it, and now it is giving resistance. Now red lead at center pin, this to the gate. Now it is open, one side open and one side diode. So MOSFET is now good. Now first we will turn on the standby power. For that purpose I will remove the bridge rectifier and I will install bridge rectifier in the circuit. Now I installed the bridge rectifier and now we will check the circuit and we will take 5 volt standby from this circuit. If the circuit is good, without PFC section we will find 5 volt here. Powered on. We can see we have 336 volts. That's good. And now we can check the voltage on the standby pin. One, two, three, 4, 5, 6. Yes, we have 5 volt. Now we detected that this MOSFET was short circuit. It caused to burn out this fuse, this MOSFET, and when this damaged, fuse burnout, all the power supply valves fail. Now we have standby voltage here. Now to turn on this power supply, we will make jumper between the 5 volt SB and PS on command. PS on command is pin number 5. 1, 2, 3, 4, 5 and number 6. So this is 5 volt SB and we need to connect 5 volt to this pin. We connected 5 volt to pin number 5 and we can check. We have 24 volt. We have 24 volt. 24. The secondary section is now started. Now we want to verify the PFC section. When we applied PS on command, this time 24 volt backlight power supply, LCD backlight power supply is present. So this 24 volt will go to the backlight inverter module. 24 volt. This is also for motherboard, the main board. 24 volt, and here is 12 volt. Yes, this is available. 12 volt available. Second 2 pins are ground. Then we have 5 volt. Now we need to verify the PFC section. In the PFC section it is using NCP1653 IC, this one, 8 pin IC, and it have feedback, voltage control, in, CS, VM, ground, drive and VCC pin. So pin number 8 is VCC. First of all we will verify the pin number 8. Pin number 8 must have VCC voltage. When we apply jumper here, at that time it will receive supply voltage. To measure the voltage we need to connect the primary ground from the main capacitor and we want to check the voltage at this pin. So it is fluctuating. We can see there is something wrong here, and we want to test the drive pin. This resistor we need to verify here because its related MOSFET is damaged, so we must verify this resistor. Resistance, and this is resistance. It is 583 ohms. No, it must be up to 10 ohms. 10 ohm, 20 ohm, 578, that means this resistor is not good. And if we check the value of this resistor, it is 10R00. If it is 578, that is wrong. And VCC resistance, that is 6 kilo ohms, that is not good. It is 4.7 ohms because one side it is startup circuit, the second side it is running circuit. So running circuit, if this resistor is damaged, this resistor is damaged, this will damage. 4R7, it is open, and this resistor is open. Now we will replace this resistor 4.7, 10 ohms and 4.7, and then we will check, might be this IC is damaged, because if this resistor is damaged, that means its internal drive transistor might be suspected. Yes, I have this 10 ohm resistor in this power supply, and I will use it. Now I connected this 10 ohm resistor here, and let's measure it from pin number 7 to the second side. Yes, it is 10 ohms. Exactly, that's nice now. And if we check this one, it is 3.6K. So we need to replace this with 4.7 ohms. It is 10 ohms. And this one is also 10 ohms. So I will use these two 10 ohms resistor in parallel. So it will become 5 ohms. If I have space, if I can install. Yes, we can install here. If we don't have the exact resistor, we can make this closer value solution. Yes, now it's good. Now I installed two resistors, 10 ohm resistors in parallel to make closer to 4.7 ohms, which was the original resistor that is damaged. This one, it is open. So now we received 5.3 ohms resistor. That's good. And now we will install the MOSFET panel, and then we will check it. Because these both MOSFETs are in parallel, this one and this one, both are in parallel. If any one is damaged, the second will automatically stop. Let's apply power and then we will see what is the result. Yes, now it's powered on. Now we will check the voltage. I applied power and now we will check the voltage. First step, we need to test the voltage here. It is 335 volt. That's good indication. And now we can check voltage at standby. That is pin number 6 from here. From here, pin number 6. 1, 2, 3, 4, 5. This is pin number 6. It is 5 volts. One, two, three, 4, 5, 6. 5 volts. Now, the lamp is in routine. Now we will apply, when we will apply PS on command. Now I will connect this switch here. So we will make push 1, 2, 3. Now when we will push this button, at that time this 330 volt, 335 volt will jump. At that time this PFC circuit, it will take a heavy amount of current to boost this voltage up to 400 volts, 390 to 410 volt. This is the range for most of the PFC power supplies. So now when I will push this button, this lamp will fluctuate. If it will fluctuate, it will dim bright for 3 to 4 times, and then it will turn off. Then it will again repeat the same function: turn on, turn off, turn on, turn off. Let's see it. Yes. When I will press, we can see this is the condition that PFC circuit is trying to start. It is a indication for good PFC circuit, because this time the voltage try to boost, because here we have, I think, 13 ampere, 26 ampere MOSFETs. So these take a heavy surge to boost the voltage, because at that time when the PS on command is applied, this voltage must jump immediately. Now we can turn on this power supply directly, or we need to use at least 200 watt lamp. Now I will connect this PFC circuit directly to the power. Now I will apply direct power to the line voltage. I am not using series lamp. Now we can check the voltage. Without PFC it is 339 volts. Now I will turn on the PFC. Yes, it is 404 volts. Before this it was 339. Now we can see when we turn on 24 volts, 24 volt on this backlight, LED backlight, and 24 volt for the motherboard. $12 volt for the motherboard, and 5 volt for the motherboard. So in this way we can verify the function of this power supply. The problem in this power supply that this MOSFET was damaged, which caused to burn out this fuse, and this MOSFET short circuit damaged the resistor in the PFC controller circuit. We installed the resistors and we replaced the MOSFET. We installed the jumper fuse, and now I will replace the fuse here. I will replace the original value fuse so that it must work in the normal condition. If you enjoyed this video, hit the like button. If you have any question, write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.